And in today's episode, among other things, you'll see the new era of drones, how AI swarms are changing modern warfare. The United Kingdom is already using a laser weapon to mitigate this threat. The United States showed a humanoid robot from Figure AI entering the White House, and that says a lot more than it seems, all right? Meta's AI glasses are becoming dangerously useful and increasingly personal. And China is using artificial intelligence to control its artificial sun, and that could change everything. Let's break all this down, along with a few other developments in new technology. Hello everyone, I'm Carlos Salvez, and you're watching Incredible Reality. Now imagine a dark and very quiet sky, and suddenly it fills with hundreds of moving dots. They're not fireworks, there are no human pilots. And just to be clear, they're not aliens, okay? They communicate with each other, make decisions in fractions of a second, and have a single goal: total saturation. The era of lone drones is over. My friends, welcome to the era of AI swarms. For decades, drones were expensive machines, remotely controlled like the famous Predator and Reaper. They relied on satellites, were operated by humans, and decisions were centralized. All very powerful, of course, but slow, expensive, and limited. Now everything has changed. The new drones known as FPV are cheap, agile, and often improvised. They cost a few $100s, but they carry destructive power that used to exist only in military equipment worth millions. And the most striking thing about all this, they are no longer alone. A swarm is not just a group of drones, it's an organism. Inspired by bees and birds, these systems work as a collective intelligence where each unit is simple, but the whole is extremely sophisticated. And this completely changes the logic of war. It's no longer about having the best tank, the best fighter jet, or the most advanced technology. Now the advantage lies with whoever can produce more, faster, and with enough intelligence to coordinate all of it. In practice, war stopped being about quality and became about quantity, about intelligent mass. The numbers demonstrate this change's impact. In a recent report from the Six Minds program on CBS News, correspondent Raleigh Williams revealed that 80% of combat casualties in the war between Ukraine and Russia are already caused by drones. Out of every 10, 8 are caused by drones. The front line has turned into an invisible hunting zone, stretching for kilometers, where any movement can be detected, tracked, and eliminated. And behind all of this is the real brain of the swarm: artificial intelligence. It allows drones to navigate even when GPS is jammed by electronic warfare. And instead of relying on the signal, they see the environment, recognize patterns, and orient themselves visually. Computer vision algorithms can identify a camouflaged tank among the trees, or even a hidden soldier without any human intervention. This raises an inevitable question. If the drone can identify the target on its own, can it also decide when to attack? The answer is yes. And this is the point where technology stops being just a tool and starts becoming the agent. And the impact of this on the battlefield is brutal. $500 drones are already destroying Leopard and Abrams tanks, which cost over $10 million. Air defense missiles, like the Patriot, cost millions per unit, while swarms of drones can be mass-produced for a fraction of that price. It's an equation that simply doesn't add up. It's mathematically impossible to sustain this kind of defense in the long run. And the swarms are already everywhere. Naval drones are already being used in the Black Sea, saturation attacks with Shahed drones, and increasingly autonomous systems that are capable of operating even without communication are already directly involved in the war. As the expert said during the report, a single person can control several drones at the same time, drastically reducing the human cognitive load. And when asked if this was like a swarm of bees, the answer was direct. Exactly, this should concern all of us. But then a question arises: how do you stop a swarm? Attempts include electronic warfare by jamming signals, but artificial intelligence is already making that much less effective. Directed energy weapons like lasers and microwaves emerge as a kind of modern lightning bolt against the machines. And even anti-drone drones created to hunt other drones. But the reality is that this race is still just beginning, and whoever masters swarm intelligence may dominate the battlefield of the 21st century. The United States, China, and other powers are already investing heavily in this because the real game changer has already happened. Drones no longer depend on humans or external signals. They can see and decide, and act almost on their own. This brings us to an inevitable reflection. What happens when machines start deciding who lives and who dies? Technology has advanced more in the last 2 years than in the last 2 decades. And maybe the future of war isn't in space, but just a few meters above the ground, buzzing silently above all of us. The problem is that this kind of attack doesn't just break through defenses, it breaks logic itself. Because there comes a point when it doesn't matter how advanced your system is. It simply wasn't made to handle infinite volume. When addressing this imbalance, a new class of weapons emerges. I've mentioned this before, but now I'll explain in more detail. Let's get into it. The United Kingdom is speeding up the deployment of a new weapon called Dragonfire, a laser system that could start operating on warships as early as 2027. The most interesting part isn't just the technology, but also the cost. Each shot costs something close to 10 pounds. Basically, it's just the price of electricity, while a single interceptor missile can cost hundreds of thousands. This imbalance is changing everything as the modern battlefield has evolved. Today, as we've seen, one of the biggest threats isn't large isolated attacks, but swarms. Cheap drones in large numbers that can overwhelm any traditional defense system. Here's the issue, Sussex. Is it worth using a costly missile to destroy a cheap drone or several drones? And this is exactly where the laser comes in. The Dragonfire can hit several drones in a row without needing to reload. Basically, as long as there is energy, it keeps operating. That's why many engineers describe this type of system as having an infinite magazine. In practice, the limit is no longer ammunition, but rather energy and cooling. The United Kingdom's plan is to install this system on Type U-45 destroyer ships that are already equipped with some of the most advanced air defense systems on the planet. In other words, the laser won't replace missiles. It will complement them, creating a new layer of defense that is cheaper and more sustainable in scenarios of continuous attack. This also solves another important problem, logistics. Less dependence on ammunition stockpiles, less need for resupply, and more autonomy and prolonged operations. This kind of movement is not happening in isolation. Other countries, such as the United States and China, are also making progress with similar systems, which indicates something bigger. Directed energy weapons are no longer just a science fiction concept. It's the kind of thing you see in Star Wars, and it's starting to become an operational reality. And when that happens, the impact isn't just technological, it's strategic. Because for the first time, defense no longer depends on how many weapons and how much ammunition you carry, but on how much energy you can generate. But changes like this rarely stay isolated. Technologies that alter the battlefield almost always end up influencing something much bigger. Here, the signal wasn't from a military test, it came from a major global decision-making center. Let's break this down now. Yeah, I know, it might seem like just another technological demonstration. But what recently happened at the White House could be a sign of something much bigger, my friends. A humanoid robot walking through the corridors of power, talking, interacting, and taking part in an official event. Figure 03, developed by the American startup Figure, made its debut at a global event focused on education and technology, and it became the first robot of its kind to take part in an executive event of this level. But what really draws attention is not just the presence of the robot, it's what's behind it. In recent months, the company has started to completely change the way its robots operate. Instead of relying on external systems, like OpenAI's models for example, Figure started developing its own artificial intelligence. An architecture called Helix 02, which is based on the concept of Software 2.0. In practice, this means that the robot stops following rules that are programmed manually and starts learning directly from data. This changes everything, because now it not only performs tasks, it starts reacting to the world. During recent tests, Figure 03 demonstrated something essential for the real world, the ability to handle unexpected human interference. In other words, it doesn't freeze when something goes off script, it simply adapts. In addition, the company claims that the robot has already achieved something close to human productivity, with tasks like sorting objects, maintaining a steady pace throughout an entire shift. And it doesn't stop there. The same system has also been tested in homes, organizing rooms, handling objects, and interacting with the environment autonomously, the company says. But the most interesting point may be outside the robot. The company's CEO invested about $100 million of his own money to create a new intelligence called HARK, a system that unifies speech, reasoning, and physical action in a single brain. And this indicates a very interesting shift. companies no longer want to depend on each other. They want to control the intelligence, the body, and the behavior of these machines. And when you see a robot like that being presented inside the White House, it's hard not to see this as something a bit bigger, much more than just technology. This is positioning. It's a sign that this race is no longer just industrial, but has become strategic. Because at the end of the day, the question isn't just who will build the best robots, but who will control the intelligence behind them. But behind all this discussion, my friends, there's a much more fundamental layer. It's not enough to just look smart. The real question is different. Can this machine keep up with the pace of the physical world, or is it just for demonstrations in places like the White House? Let's understand this a bit more. The robotics race isn't just getting smarter, it's getting faster. And the new robot has just shown how far this can go, if there's a higher limit. The Chinese company Ajbot introduced the D1 Max, a quadruped robot that reaches an impressive 8 meters per second, a speed that, until recently, seemed impossible for machines of this kind. But this isn't about speed, it's about real operational capability. The D1 Max can carry up to 30 kilograms, operate for about 5 hours, and function in extreme conditions, from sub-zero temperatures to extremely hot environments. And perhaps the most interesting part is that it can also operate in wet environments, which can further expand the types of missions it can perform. But what really changes here is the combination: speed, strength, autonomy, and intelligence. Because this robot isn't just running in a straight line. It dodges moving obstacles, adapts to the environment, and can be equipped with different modules for specific tasks. War will definitely include this. In practice, this turns the D1 Max into a versatile platform for residential applications, from security to emergency response or industrial operations in complex environments. But performance in extreme environments is still not the toughest test. The real challenge begins when this technology crosses a much more sensitive boundary. Meta's AI glasses are going to show us something. Let's take a look. This one isn't it, okay? Wait, I wish it was. For a long time, smart glasses seemed like an experiment, a curious gadget. Who remembers that Google Glass? It was something interesting, but far from everyday life. But now, that's starting to change, my friends. Meta has announced a new generation of AI glasses in partnership with Ray-Ban. And this time, the focus is no longer just technology, it's daily use. The new models were developed especially for people who wear prescription glasses, so it's no longer just a cute accessory. They now become the actual glasses you'd wear every day. And that's where the change happens. Because when technology stops being optional and becomes part of what you wear all the time, it really starts to integrate into your life. These glasses offer more precise adjustments, prolonged comfort, and a range of AI-based features that go beyond what seemed possible not long ago. Now you can log what you're eating just by taking a picture or saying it out loud. Artificial intelligence analyzes the meal, identifies the foods, and generates automatic nutritional tracking. But that's just the beginning. The glasses also start summarizing messages, retrieving important information, and working as a kind of assistant that's always present, literally right in front of you. It's a kind of Jarvis, a bit simpler but really interesting. From this point on, the change is no longer about space. It becomes about proximity, because technology is no longer just around you. It starts moving in the same direction as you. And the idea of a robot butler? Taking care of the house, cooking, cleaning, and organizing everything around? For a long time, it seemed far off, right? But now, more and more each day, we're seeing this start to take shape. LG even introduced a new home robot called Humanoid, a system designed to automate daily tasks using artificial intelligence, of course. This robot has articulated arms, hands with independent fingers, and can manipulate objects with enough precision for real tasks. But unlike many humanoids that try to completely imitate our bodies, Humanoid takes a slightly more pragmatic approach. It uses a wheeled base, which is more efficient for moving around inside homes that are designed for it, of course, and a system that combines vision, language, and action. In practice, it doesn't just see the environment with all this. It interacts with what's happening, understanding the user's intention, and turning that into physical actions. Opening doors, organizing objects, and interacting with connected appliances, all of this is now starting to happen in an integrated way. And there's a very important detail here. This robot doesn't work alone. It's part of an ecosystem. In other words, the more connected the house is, the more useful it becomes. But it's exactly at this point that a problem arises. A problem that has a solution, but is still a problem. Because while the hardware is evolving rapidly, the intelligence that controls this machine still raises some doubts. In tests conducted by universities like King's College London and Carnegie Mellon, AI applied to domestic robots, the expectation is that all domestic robots can be intelligent. For domestic robots, the expectation is that they can be intelligent. However, others interpreted the commands in a very dangerous way and, in some cases, even considered risky actions as frightening things.
Amigos, quando eles acertarem os detalhes dessa tecnologia, uma outra transformação vai acontecer em paralelo a tudo isso. Não visível, mas essencial, porque no fim, existe limite que nenhuma inovação...
That they are intelligent. The expectation is that they can be intelligent. For intelligent robots, it is artificial intelligence applied to the expectation of intelligent domestic robots. Treated as the holy grail of energy, a practically unlimited, clean, and extremely powerful source. But there has always been a problem: controlling this technology. Because inside a fusion reactor, you're basically trying to keep something similar to our sun trapped inside a magnetic field, at absurd temperatures, even higher than those of our sun. Constant instability and any mistake could interrupt all of this in a fraction of a second. And it's exactly at this point that a Chinese startup decided to change the game. Star Torus Fusion is using artificial intelligence to control the plasma inside an experimental reactor called Soonest 2. Instead of relying on fixed rules or manual adjustments, the system learns, it analyzes the behavior of the plasma in real time, it predicts instability and reacts before the problem happens. But the most interesting part is the way they are dealing with one of the biggest challenges of fusion: keeping the reaction active for a long time. Instead of trying to sustain the plasma continuously, they adopted an approach inspired by automotive engines. The plasma turns on, releases energy, stabilizes, and restarts the cycle. It's as if the reactor is quote-unquote breathing. And behind all of this is a layer of artificial intelligence that's constantly learning from the data. Using neural networks based on physical principles, the system can predict and reconstruct the behavior of the plasma, reducing errors, increasing efficiency, and, most importantly, bringing fusion closer to commercial reality. If you like this episode, please like, check your subscription, and comment if you knew about the drone issues or anything else discussed. Thanks for joining me. See you next time. Just click one of the 2 suggestions on your screen. Thanks again. Thanks, goodbye. See you in the next one, okay?